Okay, welcome back, students. So we're on to question 13 on the 2024 paper. So Michael is designing the roof of a house. The width of the roof is 6.1. Now what you want to be doing here is just, it's called split attention. You have to split your attention between here and here. See that, yes, that's true, that's there. So you don't have to deal with it again. You don't need to add this information. The roof will be in the shape of a right angle triangle of height h, okay, where h is a real number, and Michael can choose different values for his h. Okay, so basically he can change the angle and change the height. So the diagram below shows one possible design for the roof which is not drawn to scale, and so in this case we do know the height is 2.84 and we know 6.1. We're to calculate x. So when you're given two measurements of the sides of a right angle triangle and you need a third, we know that you then use Pythagoras' theorem from the trigonometry section out near geometry. So let's go on well beyond page 13. Well, there's well beyond page 13, it's page 16. Okay, and here's our formula with Pythagoras' theorem telling us that in this case x squared equals 6.1 squared plus 2.84 squared. Okay, or that x is equal to the square root of these. Which we put into the calculator now. And we do shift equals to get it, just in case it wouldn't come out in decimal. It will probably would have had anyway, but it's 6.728. It's actually a multiple of 14, but that's beside the point. So it's 6.7287 ... Okay, now it asks for 2 decimal places, so at that stage I know I want to cut in here and bring this up to 3, so which is approximately equal to 6.73 to 2 dp decimal places. Now we have an alternative where 3.12 is used for the height. So in this case you're looking to decide which of the trigonometric ratio functions you can use to solve this, and it's this one here. Now the way to look at it is that you need the opposite angle to the angle you're looking for and the adjacent. Or another way is to look at the included angle and say, well, the included angle is the right angle. So when the included angle is the right angle, you're using tan, which you're doing here. So this is the one to use. The angle is not called A, it's called theta, and it's equal to the opposite over the adjacent. Now we're going to inverse tan both sides, which basically means the tan from here will end up here, and it'll have a -1 on it. Let me show you what that looks like. Inverse tan 3.12 over 6.1. Just to say, I forgot, but I often leave a gap here so that you can cross out the tan here and bring it across and call it inverse tan. So that's just the same as we do always in algebra. We inverse the function that we don't want to get rid of, so we know what theta is. So on the calculator it looks like shift tan, fraction bar, 3.12 over 6.1, and we close the bracket after coming out from the fraction and hit equals. Okay, to give us the angle in degrees, as long as your calculator is set to degrees here, 27.088. Okay, truncated, and then we look to see correct to the nearest degree, so we're going to say is approximately equal to 27 degrees, 0 decimal places. Okay, I've Notice they keep seeing 27 degrees, and they say is an element of n instead of naught dp. Nice. Okay. Now a different part of the roof is in this shape, somewhere else in the house. It's an isosceles triangle with base 14. In this part of the roof, Michael makes an attic room by putting in the two vertical sides with x. The distance from B to C is 8 meters. And the total height of the roof is y meters here. Okay. So the rest of the information again is causing you to split your attention because it's all given to you in the diagram. Okay, use similar triangles to show that x. Okay, so I'm not even going to talk about this. Let's go to similar triangles. What's our definition of similar triangles? Similar triangles are angles with the same triangles. Okay, 1, 2, 3. They can be scalene. They don't have to be any particular type, but they have to have the same triangles. So a nice way to draw two similar triangles is to just draw a triangle and then put in parallel bases. Okay, so the property of similar triangles is that the ratio of the sides, the corresponding sides, remain the same. So we're going to use that to exploit this. So in our similar triangles, we have the largest triangle has 14. So let me see, can I figure this out? Let's say we're going to use the fact that there's symmetry there. So let's go with, these are our two triangles, the bigger of the two and the smaller of the two is out here. So just model that here with 7 and 4 here. Okay, meaning we have 3 here. Okay, so this is 4 and this is 3 in other words. So we'll go along with this and we have y here and x here. So now here's how it works. Y over 7 in the large triangle has to be the same as x over 3. Now if we start studying this, we see that x is the subject of the formula, so this 3, the divide by 3, has to be cancelled out, or the inverse operation, which is multiply by 3. So we multiply up to 3 and we get 3y over 7. Okay, which is what we wanted to show. Okay, so we're done. Driving on from there, the area of the shaded region ABCDE, okay, is 12 square meters. Great. Using your answer in part C1 or otherwise, find the value of y. Okay, so we're going to use symmetry again, and we're going to take this as being half, as in 6. I'm going to identify this as a trapezium. Now you can decompose it into two triangles, but there isn't any need, and it's one of the first things we learn in area and volume, that the area of a trapezium is the sum of the bases, in our case y and x, divided by 2 times the height. So let's see how we can deconstruct this. It's like the bases are lying on their sides, y and x, and the height is 4. Okay, so we're going to apply the formula that the area equals, we'll just use the formula from the tables first so we can get our head around it, times h. Now we have x can be replaced with 3y over 7. The other base is y itself, all over 2 times 4 equals 6. So let's multiply that 2 up here. We get 12 equals, and let's divide down that 4. So you have 3 here and you have 3y over 7. Now if I have to add on this, it's best to call it 7y over 7. Okay, so I have in total 10y over 7 equals 3, 10y equals 21, y equals 21 over 3, 21 over 10, or 2.1. Okay, now let's see if we answered the question. Work out the value of y, 2.1. Let's go to our marking scheme and see how we did and look for alternative methods. So let's go through it all. First off, we got 6.73 correct to 2 decimal places. We got 27 degrees. They could have used tan, but they used the same method as us to show that the ratio of the sides in the smaller and the bigger, proving that x is equal to 3y over 7. And then using half the shape as we did, they actually split it up into the large triangle minus the small triangle, but that's actually missing a trick. The important thing is we get 21. Or hold on, look down here. They used a square, a rectangle area. Yeah, I was disappointed they didn't use the trapezium because it's the most direct method. But the trapezium method is a correct method. You could use either of these two methods as well. Yeah, the important thing is that when you're doing problem solving, there's always more than one way, and you want to use your strategic competence to pick the best way, and by far the best way is to use the trapezium. Okay, that's it. I'm just going to leave the trapezium in the picture when I take a picture of it to share with you. So as always, I'll see you in the next one.